OpenMP program. So this session will help you all to reinforce the knowledge you have been taught by Professor Prasad in the previous session. So his PhD students will conduct this session for hands-on on OpenMP. So I request everyone to start this session.
Is mic. It's okay. So, everyone, let us start OpenMP programming. Before that, you have to log in. Hello, everyone. My name is Dibya Kanti. I am a PhD student. Today we will do a hands-on session on OpenMP programming, and for that you need access to a Linux system and a multi-core system. So if you have a Linux multi-core system available with you, then you can start. If you can install in VirtualBox, it is okay, and you have to allocate the course to that also. And otherwise, we have some systems available with us in Padam Vidya. And so
you can directly access Param Vidya.
Yeah, you can directly access Param Vidya.
For that virtual box is not needed.
No, for that VirtualBox is not needed. You can do from PowerShell. Everybody has PowerShell in the system, then you can connect through SSH.
If you have Linux, you can use OpenOne terminal through SSH. You can enter to Param Vidya. That is the way. Okay. If you don't have Linux or Windows in your system, then from Windows, instead of VirtualBox, you open one command prompt of ourselves. Okay, and then you log in. That's it.
Yes. Above is the command, SSH command. This is the port for logging remotely, and you have to join any of the teams. You change this part. This is team 6. You can change it to team 1, 2, 3, 4, or 5, or 6, and the corresponding passwords are written.
Okay. You can log into any team. So 6 login has been created. But once you log in, you please create one folder with your name. So that there is no clash or conflict. If you do not wish to use your name, it's fine. You can use something which will not clash with any other persons. And if you create one such, then MPI can also be done on that. And at the end of this workshop, you can copy that folder and you can keep it with you for further study or further exploration.
Sir.
Yes.
Can we switch to another machine outside and so that we can?
So right now you want or later?
No, right. If it is possible, then we can connect to the.
If that system is open, if that system port 22 is open, you can do that one.
Yeah, that is.
Then you can do that.
But SSH is not working always.
SSH is not working in your system. Then your system has an issue. You are not reachable.
No, SSH exchange key identification, some connection reset by here.
Since we have only 2 hours time, in order if you have to write the code from scratch, it will take some time. So this we have already provided the OpenMP codes in the OpenMP folder in day one hands-on folder. So if you connect to Param Vidya, you can access to that folder. Otherwise, you have to write your own code from scratch. Pass. Okay. So this was just an example. Okay, the password is available.
Yes, so all of you from your PowerShell or terminal type this one SSH space -p space 4422 space minus small o. Careful about the capital or small, okay? Case sensitive. User, U capital, without space, known, without space, host, without space, file. UKHF will be capital, rest are small. It is case sensitive. Equals to /dev/null. Space team 1 2 3 4 5 6 anything @paramvidya.itkgp.ac.in. Then the password will be the team name you have picked accordingly. Yeah, it's better to write it down on your notepad. Write it down on
Exclamation mark. Two exclamation marks.
Slide notes and during the process you are disconnected. Again you can
Password. Help this.
Password though, you must be making some mistake in entry. Find the ये वाला So while you are typing, the password will not show, but it's getting inserted. Okay?
Directly from PowerShell.
already connected but
The folder is shared in the mail ID.
Folder is shared in inside that day one
I mean, in
hands-on folder.
the mail ID, the same mail ID.
No, not in mail ID. It is inside that folder. When you enter that Paramvidya, inside the Paramvidya.
You create a folder. Over.
In order to check the system configurations, you can run this command ls-cpu. This will show you the number of cores your system has and the number of threads per core and the number of cores per socket, and this information is available.
So please note here the number of CPUs are 96. So threading can be done up to 96. But one thing you also remember that all of you will be using 96. So it will be 96 cross number of physical participants. Okay. So as per my discussion, so it will not be as fast as a serial.
Okay, showing the specification for Paramvidya.
But later,
Yeah, this is the Paramvidya specification.
today evening also,
In my
when
machine also I can see that.
then you definitely see that there is a speed up.
Now you have to check whether OMP is installed. Locate open quotes root omp.h.
Locate is the command.
Yeah, locate is the command.
Slash
/omp.h. It will show you where OMP is installed. Hello, Rumaila, you have any doubts? Hello?
পাসওয়ার্ডের পেজটা যাও অনেক পাসওয়ার্ডের পেজটা পাসওয়ার্ডের পেজটা
পাঠিয়েছি।
এখানটা দিয়ে রাখো
Any of the online participants have any doubts? You can ask. If you do not have any doubt, then you can lower your hands.
Hello. Hello.
Hello, hello. Yes, yes.
Where are you?
Hello. Shh. What is your doubt? Danny,
Yeah.
there is online doubt. What is he saying? Listen to. There is somebody speaking on the mic. Online. Hello.
Hello, sir. A very good afternoon, sir. Hello, am I audible? Hello.
Yes, can you type your query also? It will be helpful if you can type it.
But sir, the chat is only available to team members, sir. It is not open to all, sir. So I myself, I'm Saurabh Roy. Trying to.
Please type in the chat section.
It is a
Q&A section or chat section.
It is disabled. It is disabled for non-members.
You're not audible. You're not audible. Please write in the chat.
It is disabled, sir, for non-members. It is coming like that, so I'm not able to. Actually, I'm trying to log into the ProgrammingTips server from our Linux machine, and I'm trying to copy the airfoil code. It is actually showing up an error. So.
I think they're not able to connect via ProgrammingTips.
Is it available outside the network?
Yes, it is available outside also with the port.
So it is, the connection is not stable. Hello, the connection is not stable. It is repeatedly giving the broken pipe error.
Connection is not stable.
Yeah, it is giving the broken pipe, loop disconnected, broken pipe error for only the connection system.
Those are the issues, connection issues. I cannot help with that, but I have also provided the code.
Okay, sir. Okay. We'll follow along just like without logging only and follow along this. And I'm trying to copy one particular code, that is the airfile code, so that SCP copy is also not happening.
Not audible. Please, you can write in your chat. Oh, passwords. Passwords. 3, 1.
Hello. Hello.
Hello.
Hello. Yes. Hello. Yes.
Hello.
Hello, hello, yes, yes.
Hello, am I audible?
Sir, what is the password for team site? Team number is
Hello.
there.
Yes, yes. You can speak. Team one to all our passwords. You can join any team from 1 to 6.
Hello.
Hello, hello, yes.
Hello, am I audible?
Yes, you are audible.
Okay, so I couldn't connect, and every time I typed the credentials, it shows that the connection is refused.
Connection is
Refused.
received. Okay. And next, what is saying?
So I just couldn't connect. That's the problem. I couldn't connect
Okay.
in the Paramvidya.
Okay. One thing you can do. Can you share the screenshot via chat?
Yes, sir. Will do that.
Uh,
Sir, I have also mailed the issue to
Actually, the
CPS.
chat section is not available for here. I can
Yeah.
only have the Q&A. In the here is the chat section is not available. Yes.
Okay. Chat option is
Chat
disabled.
option, chat option is
I
disabled,
have
sir.
the screenshot, but
Okay.
I
Chat
don't
should
know
be
how
enabled.
can I.
Let me try to enable it. Correct. Or you can ask the question in the Q&A section. Yeah. Uh, Host key verification failed. Okay. Host key verification fails because you are not typing the uh, CAPTCHA correctly. And connection timeout is because of connection issues. Okay. Okay, I will look at the Q&A section. You can share your queries directly in the Q&A section instead of the chat section. Are your queries clear? Are your doubts clear?
Yes, sir. Yes, sir. It is clear.
Okay. Uh, is chat section is not accessible to you, but can you see the meeting chat? Means what we are sending via the chat. Can you see that
No,
online?
sir. Chat section is also not visible. It is not typable and also not visible, sir, to non-members.
It is
Only,
not
sir.
visible.
Yeah, it is
Not
not
only.
visible, sir.
Okay, okay, okay.
I'm only able to communicate through mail.
Okay, okay. So I can share the chat is not visible to the team. Chat is not visible online. Chat is not visible online.
But we can do this. It should be typed in capital A-A-W-E-R-E-R-S-E. Huh? S is small. A
Okay, so one thing I can do, I can share these slides. I can download these slides and share it.
Yes, sir, that would be very helpful, sir. Thank you.
Chat is visible online. Somebody was saying it is not visible.
It's okay now. Okay.
So command to open the files.
Is there anyone whose connection is not working still now? They can.
Nano. You have to use the nano text editor. Okay, chat is not visible to some people.
But any updates
So
everyone.
what I can do, I can share the files in the class recordings. I can share the A1. I can share the it is shared in class materials.
কমান্ড লাইন থেকে বার করার চেষ্টা করছি ওখানে তো নেই
Command line আছে nano text editor. Nano text editor. Upload. Okay. Okay. In day one hands-on session material, the PowerPoint has been shared. The PowerPoint has been shared. The codes have also been shared. And outside the class material, the screenshot will also be visible. You have to go to the class materials. In the class materials, the screenshot is visible and the PowerPoint is also shared. Okay, now let us move on. Okay, so the first program is the Hello World program. So you just have to change the code a little bit. You have to write hash OMP set num threads. You can set it any number, okay, and then you can write hash pragma OMP parallel. Now if you provide num threads also, then since it has a higher priority, it is at a innermost level. So when you assign num threads at 8, the actual number of threads allocated are 8. But if you do not do num threads, then it will take the 4 value. Okay. So here the output gives 8 threads. Yeah, you have to run it. For the execution, yeah. You have to. Hello.c.
Can you just show the command for running?
Command to run. First, go through this file, and after that, the command to run is gcc -f openmp. -f openmp is the library, OpenMP library. Okay, and then you execute it with omp hello.c. It is available in the OpenMP folder in Paramvidya /omp hello. And because you provided this OMP get thread num. So whichever thread is executing this printf statement, that thread will be printed alongside. Yes, that if it is from the 0th thread or 0th core, it will print 0. If it is from 7th core, then it will print 7.
Each thread will be executed by one single core.
Usually, because if the number of threads is less than the total number of cores, then each thread will be allocated to a different core. And if it is more, if the number of threads allocated is more than the number of cores, then some cores will have multiple threads allocated to them.
How to access that code, sir?
Nano OMP hello.c.
So here the number of cores is 96.
96 total number of cores.
Then I can
Increase. You can
I
increase.
can assign 150 threads.
You assign 150 threads, then it will be divided among the 96 cores.
ন্যানো ওএমপি হ্যালো.সি খুলছে না কেন? ন্যানো স্পেস হবে?
Space, space.
না হচ্ছে না তো ওএমপি হ্যালো.সি।
Okay, okay. Let me show you. So, okay. You can open the code with nano OMP underscore hello.c. You can change the number of threads. So I can do it 96 or any number. And then DCC minus F OpenMP minus O OMP hello OMP hello.c. Then I execute it OMP underscore hello. So
Sir, we don't have the example copies in our team.
you have the examples in what Paramvidya.
But in which team?
In all the teams.
No, it's not there.
Not in all the teams.
It's
Which
not
team
in
you
all.
have joined?
I've joined the team 4. Should I show you?
Team 4.
Yes.
In team 4 you have joined day 1.
Okay.
Go to day 1 hands on. Day 1 underscore hands on.
Yes, there is on
Go to OpenMP.
open.
Yeah, inside.
How it is done.
Okay. Mic is not okay. Okay. Now it's working. Yeah.
Can I get the code in which the thread is executed? Code number.
Yeah, that is given side by side.
That is thread number.
Oh, code number you want. साढ़े 4:30 से 6:30. Okay. Code number. Actually, code number is not available. Thread number is available.
What is the next one?
Okay. Are you ready to move on to the next slide? Is the class ready to move on to the next slide? Okay.
Sir, you have written that
Slightly different maybe.
What did you run the file? What did you run the file? Why is
Yes. Command. I wrote once, but it doesn't work.
okay, that is the name of the output file. We are defining the name of the output file as OMP, and this is the input file. This fact we are telling we are compiling this using OpenMP, and we are telling the output file name should be OMP. That's why when we see we have
Output file also.
okay to run that we have to do this. This is what is the output.
Slash select
And the name of the output. Sir, if we have OpenMP installed in our own Linux system,
Yeah.
can we do it without coming into SSH and doing it?
Yes, yes, that is what you have to do ultimately. This is just for this session.
Okay, now we are not accessing those servers to do this computation, no? Like, we are
Right
not
now-
directly accessing those supercomputers to do this work? No.
No, no, that's not required. That's just for convenience. Connecting to the supercomputer cluster is just for your convenience. You can do in your own Linux.
This work is done by our own laptop.
Yeah.
Yeah, you can do in your own laptop, but the number of cores available will be less.
Now whatever we are doing now, it is on based on the supercomputer.
Yeah, because supercomputer has 96 cores. Your own system has 8 cores or 12 cores.
Okay, 96 CPUs. The whole thing is to use the system.
You can compile and execute, but it's better to go with the flow. Yeah. Everybody is done with this program. Let us move on to the next slide. So, when you specify, there are 3 ways to specify the number of threads, has also been explained by Sir. So, when you write in the command line export OMP num threads equal to something, then this has the lowest priority because this is outside the program itself. So, if nothing is specified in the program, then as a default number of threads, it will take 16 here, as given here. Okay. It will be the default number of threads if nothing is specified in the code. Now, if OMP set num threads has been specified in the code, then that will have a higher precedence. And then you provide num threads inside hash pragma OMP parallel for, then your number of threads will be defined by this num threads only, because this is the innermost. And as an example, when we see this code, in this code also, set OMP set num threads 4 was defined, but inside there was hash pragma OMP parallel num threads 96. So what happened? All threads executed this printf statement along with the thread numbers. How many threads did they? 96 threads did that, because num threads was 96. Okay.
Why did we define it twice when the higher priority one will obviously take?
Yeah, just to as an example that this is the higher priority one.
Okay.
Okay. Okay. So now we will do a slightly more complicated example than hello world. So we will be calculating pi through the integration method. There are multiple methods to calculate pi, but for this class we will do through the integration method. So, okay, 1 by 1 plus x square. What is the integral of 1 by 1 plus x square? Tan inverse x. No observation required. This part में क्या फर्क होता है? Direct. Okay. So, integral of 1 by 1 plus x square is tan inverse x. So, if we give the limit 0 to 1, then what is the output? Pi by 4, because tan inverse x is pi by 4. So, y is pi by 4, then pi will be 4y. So 4 into integral of dx by 1 plus x square, that will give you the value of pi. Okay. So now dx is a very small number. So it is a continuous integration is a continuous process. But we can convert it to a non-continuous discrete process also, where instead of the integral we'll do a summation. So here dx will be replaced by h. The value of h is 1 by n. So where I can define a variable I. So when that variable I goes from 0 to n, then the value of x goes from I into h to n into h, where n into h is 1, because h was defined as 1 by n. So we converted this integral into a summation, where pi is equal to 4 into sigma summation h by 1 plus I into h whole square. We have to do from 0 to n. So you know, in integral the value of dx is infinitesimally small. So that is when the integral is correct, when the value of dx is infinitesimally small. But when we are doing it discretely, we cannot do it infinitesimally small. So n is the inverse of h. Since n is the inverse of h, to make h infinitesimally small, we can make n as large as possible. So we can define n as a very large number, then it will take a long time to calculate pi. And if we take n to be a very small number, then the calculation of pi will not be exact. The calculation of pi will be incorrect up to some decimal number. It will always be incorrect up to correct up to some decimal number only, and it will depend on the number of n, the size of n. So if you increase the n, your precision of the value of pi will increase. Anybody has any problem with this slide? Yeah, that is another technique for pi. We are not discussing that in this, but that is another technique. So everybody clear with this? So next slide. So in this slide, we have written the CDL code for the calculating the pi. So we are using long int defined as 10 to the power 9. Dx is 1 by n. Sum has been initialized as 0. Val and y are two variables initialized as 0. So there are two variables, start and end. So in order to check the time taken by the program, so at the point start, we do OMP get time, get W time, and at the end we'll do OMP get W time. We subtract n minus start, then we get that elapsed time. Okay. Now inside this elapsed time part, our integration or the summation operation is done by the via for loop. So the for loop will go from 0 to n, and y will be incremented by dx, and the value will be 4 divided by 1 plus y into y, and then finally sum will be plus equal to val. So all the values will be summed, and you will get the value of pi at the end. So then you have to multiply the sum with dx. That will be the value of pi. So everybody clear with this pi program? So let us go to the parallel program. Okay. So in the parallel program, you will see the 3 hash pragma lines, which are different from the serial code. So the first hash pragma is hash pragma OMP parallel shared sum private val and num threads 8. By default, everything is private. So yeah, you don't have to provide I and dx as private because that is private by default. But if you want, you can provide I, dx, and val all as private. But sum will be shared because it has to be shared across all the threads. Then only you can get the correct sum. But here is another problem. If we do hash pragma OMP for and there is no atomic or critical section, then what happens? Then there is a race condition. So there are multiple threads, all are updating the value of sum. So when they are reading the value of sum, so another thread is suppose writing at the same time. So one thread will be reading a stale value of sum and will be updating it. Okay, so now the sum has been wrong. The sum has been corrupted. So that is the race condition. In order to overcome the race condition, we use critical section or atomic. In when we do critical section or atomic, the log for the variable sum will be uh, the log will be selected for one particular thread only.
That will be serial.
Yeah, that will be serial. That part of the code will be serial, and the log will be log for the sum will be available to only one of the threads at a time. So only one of the threads will be able to update the value of sum. So this makes that program serial at that point, because only one thread can update it at a time. So without this atomic, there will be race condition and there will be errors. But now, because one has to acquire the log, the threads have to acquire the log and they have to release the logs. That takes a lot of overhead. And when you use atomic or critical section, it will take, I will show later, that it will take much more time than even the serial code when you use atomic or critical section. So for that, we have another method called reduction. So when we apply reduction, then the atomic is handled, atomic or critical section is handled by the CPU itself, and it does the same thing. Uh, it updates the values, the sum values. For it keeps a copy of the sum values for all the threads, separate sum values. Okay, so instead of a single sum, all the threads will have its own sum. Okay, and then it will add all those sums by a reduction operation. Okay, and that is a complicated mechanism not covered in the scope of this workshop. That reduction operation will do the sums in parallel. Okay, means half of the sum, then another half, and then means binary search. You do half the part and half part, and then again sum. It is a complicated mechanism, so not covering here.
So, did you try binary search over this parallel code?
No, not required, because the reduction operation handles it for us.
No, I'm thinking about the functional algorithm. Binary search is part.
No, binary search is not been implemented.
Quick shot.
Quick sort. Actually, sorting will be beneficial. Even merge sort will work very nicely with this. And binary search will also work nicely.
Binary search is only one part we are using.
Yeah, but it is log n time, so it will not be very useful. So I think merge sorts and all the will be helpful to do in multiple. Yeah. Merge. Yeah, there is, I think, parallel merge. There is parallel merge in MPI also and in OpenMP also. So everybody clear what reduction does? Reduction has its own copy of the sum variable, and it will sum all these sums. Every thread has its own copy of the sum variable, and then in the background process, it will add all those sum variables and give us the result. So that critical section is not required when reduction is applied. So because the critical section and atomic is not required, what will happen? There will not be the acquiring and releasing of the logs. Overheads will be less. And we can see for the parallel for reduction versus the serial code. The serial code took 3.85 seconds for 10 to the power 9 value of n. N is 10 to the power 9. So we are varying the number of cores and we are seeing the time elapsed. So when the number of cores is 1 for the serial code, the time was 3.85 seconds. Then doubling the number of cores, even using reduction, did not help because it shoot up to twice. And then even using 4 cores, the serial program is faster. But then from 8 cores onwards, the parallel program is becoming more efficient. So it is taking 2 seconds for 8 cores, 1 second for 16 cores, 0.59 is 0.6 seconds for 32 cores, 0.43 seconds for 64 cores. I have written 96 cores also here because 96 is the total number of cores in Param Shakti. It is Param Vidya. It is taking 0.26 seconds. And if we increase the number of cores further, more than the number of cores available, then also it is taking almost the same time, 0.26 seconds. So there is no improvement observed when the number of threads are more than the number of cores. So the optimal will be to use the maximum number of threads available. Or if we are running multiple programs and you want to divide, then you will not use the maximum number of threads, you will divide among the different programs. Okay. Now we'll cover, first let me check a bit the online teams. Anybody has any doubt in the online section? Q&A. How to install OMP? Okay. In Linux, sorry, forget. In Linux, Debian is sudo apt install the libompd. libompd, something like that. Libompd. Q&A. See the Q&A. Okay, recordings. So you can execute that parallel for reduction code, pi parallel for reduction, and execute it for different number of threads. And also you can execute the serial pi, and you can compare the results for yourself. Check the accurate time taken, time elapsed yourself. Okay.
It is taking more than a minute to do in.
You are doing without reduction, I think. The other codes require more time than serial, so you have to do the one with reduction. Okay. So I think the name is
What is the name of that file where that reduction?
okay. The name is OMP pi parallel for reduction.c. OMP pi parallel for reduction.c. Notice that both y and sum is shared variable here. If y was private variable, then again you will have that problem, because one of the threads will update it differently, another of the threads will update it differently. Then when the val will be calculated from y, that will be incorrect. Okay. So
what is the file name?
file name is omp underscore pi underscore parallel underscore for underscore reduction dot c. Nano, you have to do nano omp underscore pi underscore parallel underscore for underscore reduction dot c. Yes, there is a chat. Is there any difference between OLP pi parallel for reduction and OLP pi parallel for? Yes, because OMP pi parallel for, let me open that code. OMP pi parallel for without the reduction. So without the reduction, what you have to do, you have to create a different sum. You have to create a different sum. So in order to avoid the critical section, you have to create a different sum for each of the threads. So here, I created a different sum for each of the threads and shared the entire array. Shared the entire array sum, and all the other variables are private here. So So when you do OMP by parallel for without the reduction, then a lot more work needs to be done. The number of lines inside the parallel increased, and the number of lines outside the parallel also increased. Means it is not enough to just add the different sums. You the reduction part, main reduction part, that is adding the values of the sum together, that is missing. That is outside the parallel section here. That is in the serial section of the code. So that is why it is slower than reduction. Here, for each of the threads, you are calculating their individual sums. Up to that, it is parallel. But when you are summing all the individual sums, that part is serial. So that is making it slower compared to the for with reduction. Please share the connection details. Connection details. Okay, here. Means whatever I wrote in the chat, I can just. It is available in the class materials. Is available in the class materials. It is available in the class materials. So now let us move on to the next part, static versus dynamic scheduling. Okay, everybody pay a bit attention. So now we'll compare the uh, performance of static versus dynamic scheduling. So this is also the reduction code only. Okay, I have not written in details. This is also the reduction code only. So when you vary the chunk size in static versus in dynamic scheduling, there is a difference in the time taken. So in static scheduling, sir might have explained in the class that the chunk sizes are allocated in a round robin fashion. So if the chunk size is 10, so 10 is allocated to thread 1. At the same time, thread means ID 11 to 20 is allocated to thread 2. Then the other ID from 21 to 30 is allocated to thread 3. So the IDs means the for loop. For loop has IDs or I, whatever. The iterator value. The iterator value will be divided among the threads according to the chunk size. Okay. So at a time, if you are 64 threads, then 64 into 10. At the first slot of time, 64 into 10 iterators will be allocated. After that, again 64 into 10 will be allocated. So if the chunk size is increased to 100, then each thread will be allocated 100 iterators at a time. So if 64 threads, then 6,400 are allocated at the first time slot. And at the second time slot, again 6,400 will be allocated. So this is the type of static scheduling. And then in dynamic scheduling, also we can specify the chunk size similar to static scheduling. But here which means they do not uh, work in lockstep. Okay, the allocation does not work in lockstep. So uh, all the threads, so there will be a kind of parallel synchronization. There will be a kind of synchronization until the entire, all the threads complete the execution of the chunk size number of iterators. Okay, so it will wait for that time until all the threads have completed the execution. Ah, but in dynamic there is no waiting. What it will do, once uh, any thread has finished its chunk size number of uh, iterators, it will take its next iterator. It will calculate which one it has to take, and it will take its next one. Okay, so dynamic scheduling will be, does not work in lockstep, does not work in synchronized manner. It works in an asynchronous manner, and it allocates the iterators to the threads whenever it is available. But according to, at the 10 chunks at a time, if I give chunk size 10, it will give 10 chunks at a time. Then it has to select again. It has to select again which thread will be getting this chunk. Okay. Then again it has to select. So that selection time, that scheduling time is higher. That scheduling overhead is higher for dynamic. So when the chunk size is less, then the dynamic scheduling suffers. So you can see that for chunk size 10, the time is 4.573, but at 1000 or 10,000, it is almost half of that of static scheduling. In static scheduling, it is 0.4, and in chunk size 10,000 or 1000 dynamic scheduling, it is 0.26. It has reduced a lot.
It's because of scheduling.
Yeah, because the scheduling overhead is lower when the chunk size is higher.
For 10, it is taking lot time is consumed in scheduling.
Yeah, the scheduling overhead is higher when the chunk size is less. Anybody has any doubts? Please look at this slide. Everybody look at this slide of static versus dynamic scheduling. So, sir has explained in class what is static and dynamic scheduling. So, when you differ the chunk sizes, you'll see no difference in the static scheduling, because for static scheduling there is no extra overhead for scheduling, because there is a proper algorithm that which thread will get which chunk, but there is no proper algorithm which thread will get which chunk in dynamic scheduling. So there is a selection involved. Whenever one thread completes its chunk, it has to select its next set of iterators it will work on. Okay, or uh, it has to be allocated, so that that scheduling overhead is higher when the chunk size is less for dynamic scheduling, and when the chunk size is higher, the scheduling overhead is lower, and that is why it takes less time even than the static scheduling. Okay.
Sir, can you repeat conceptual exercises? Small.
In starting, there is no scheduling overhead. There is no scheduling.
No scheduling overhead in static.
If there is no much difference in time, right? When chunk size.
Yeah, that is why, because there is no overhead. There is no overhead in static scheduling. No scheduling overhead.
Then why is it decreasing and then increasing time? Static.
Oh, that is minor fluctuations. That is fluctuations. I know. I don't think it has some special reason.
So every time we run the 100 chunk size, the time will change or it will be
And it will change. It will change because the other processes are also being allocated at the same time. It is not that only
like
this
barrier
process.
waiting time will decide the time of execution.
Yeah, barrier waiting time will determine. And this value will differ a little bit every time you run. But
Dynamic when subset is very large, it is completing very much faster, right?
yeah, it is completing faster because now you have to allocate less chunks. Means the number of chunks you have to allocate is less.
So the code is little right. Only some code will get utilized, right?
Uh, Actually, when n is very large, so n is 10 to the power 9, and your chunk size is 1000 or 10,000. Still, you have to do 10 to the power 5 chunks. Okay.
Thank you.
Now, there are other runtimes I have experimented with in my own desktop. So, the serial code took something like 3.15 seconds. That was an octa-core desktop. In an octa-core desktop, the serial code took 3.15 seconds, and the for with reduction took 0.53 seconds. The for without reduction took 6.9 seconds, means double the serial code. And with the atomic construct, it takes almost 20 times because there is that uh, mutex lock. That lock has to be acquired and released, and it will that acquiring and release will occur for 10 to the power 9 iterations. Okay, so it will be like it will take a lot of time for that mutex operation. That is why atomic is much slower and usually not used. Okay, so instead we use reduction. So next we'll look at matrix multiplication. Matrix multiplication serial code. So the first three are just initializations. Okay. Uh, the array A, the matrix A has been initialized as I plus j. Matrix B has been initialized as I multiplied by j. And matrix C has been initialized as 0 because it has to be initialized as 0. And then we have the matrix multiplication in the last for loop. The serial code is clear to everybody?
Yes.
Okay. So now, when we just have to do one change in hash pragma, you have to do hash pragma outside all the for loops. Outside all the for loops individually, and we have to do a scheduling. You can do dynamic or static, any scheduling, dynamic and with higher chunk size does better performance. Then collapse 2. Okay. So even in this three-dimensional, collapse 2 will only work because collapse 3 has unintended consequences. Collapse 2 works better. Okay. So the collapse does what? Converts the nested loop into a simple loop. Okay. So it will convert the nested loop into a simple loop only, and in 2D loop into one loop, one dimensional loop, and then divide it into chunks according to scheduling, and it will then parallelize and provide the chunks to the threads. So first it will serialize, means not serialize, it will convert the 2D for loop into a 1D for loop, and then it will divide the iterators among the threads. Okay, so these are usually rows and columns, but it will be combined once more. Yeah. So collapse does what? We have two we have a nested loop, right? There is for inside another for. Then it collapse converts into a one single for loop instead of a nested loop. So it has to be perfect. Collapse has some very constant situations in which collapse can be applied. So between this for loop there must not be any code. Between the nested loops there cannot be any other code. So it has to be a proper nest. Only when proper nesting is there, then collapse can work. Then it will convert into a one-dimensional. So if it is NRA number of rows and NCA number of columns, then it will be NRA into NCA, and it will go for that number of means the loop will be of that size, NRA into NCA, and inside this operation will work, and then that will be divided. This for loop, this one-dimensional for loop will be divided into the threads.
On what basis? Like if chunk is 2, then it is divided by.
Yeah, if chunk size is 2 and it is static, then the thread 0 will get the first 2, then thread 1 will get the second 2, and then in the round robin way. Okay.
Sir, you said that for 3 for loops.
For 3 for loops, when I am doing collapse 2, then what happens? Yeah. For 3 for loops, when you are doing collapse 2, then all the 3 nested loops will not be collapsed. Instead, 2 levels of nested loops will be collapsed.
Only 2 levels of
1 and 2 levels will be collapsed, and the final level will work in a serial fashion. Yeah.
Only 2 will run in parallel.
Only 2 will run in parallel, and the most inner one will run in serial.
After these 2 run, then it will be in serial.
Yeah, it will be in serial. So that code is also provided in the Hands-On OpenMP folder, the matrix multiplication also. So I had done a calculation. A matrix A was 1000 by 300. Matrix B was of size 300 by 500. I got a serial time of 0.59 seconds. And the 8 core, only using 8 cores, the parallel time was 0.17. Means a very high reduction, means almost 4 times reduction or 3 times. But that was using static and chunk size of 10. When you use dynamic and chunk size of 1000, it is 0.149, means even less. As you saw, the dynamic and higher chunk size works better. Okay, so now the slides are over, but I will want to demonstrate it. Okay. So
this is running on Paramjit.
Paramvidya also it is there. Matmul. Let me show the parallel code just for understanding. See, outside the entire section, we did #pragma OMP parallel, and we shared A, B, and C. A, B, and C are the matrices. The matrices will be shared. Okay, and the chunk size and the number of threads is always the same, so it can be shared. I, J, and K are internal and internal to the threads and are private, and number of threads 8 is provided. Now there is the first #pragma inside this #pragma parallel. This is for initializing the matrix A. Collapse 2, using collapse 2. And then again initializing the matrix B using collapse 2. Then initializing the matrix C using collapse 2. And then doing the matrix multiplication again using collapse 2. And finally you get the OMP get time and this. Let us run this small example. This is first let me show this small example. Matmul parallel small example.c. This is I have created a small example with less number of less matrix size to see the correctness whether the output is same for the parallel and serial. Okay. So minus NMP parallel small matrix multiplication parallel small example dot c. Okay, that's c dot out. This is the output of the C matrix using parallel. You see that this was a very small matrix, so the time elapsed is 0.001. For the serial code, time elapsed will be much less when the matrix size is smaller. So let us do the serial code also. Yeah, this was the parallel code. Now slash a dot out. Yeah, you can see that it took much less time, 0.000008, much less than the parallel one, because the matrix size was smaller, so the overheads are higher. So when the matrix size is larger, then you see the improvement.
Sir, overheads are only one overhead is there, only scheduling overheads.
No, there are other kinds of overheads. There are synchronization overheads, and there are collapse also requires some overhead. So let us do the normal matpal serial. Okay. Dot slash a dot out. It took 0.60 seconds. Okay. And now I will do the parallel one. I have commented out the matrix because it will be very large. So commented out the matrix, output matrix.
Sir, before simulation, what was it?
What?
After serial, sir, the second one you did just now.
Yeah.
What did you execute?
Dot slash a dot out.
Like
A dot out. Just.
serial.
Yeah, first the serial, matpal serial, then the matpal parallel.
See, every
Okay.
time we compile, that A dot output will be the output generated for our compilation. Every
Like
time
you first you generated parallel. First,
Another is big matrix.
the second two. Yes.
like
You can see that this one has matrix A size is 1000 by 300 and matrix B size is 300 by 1000. Yeah, big matrix.
The day you are defining that your output file should be with this name. But if you are not defining your output file name, it will be as A
So
dot
this
output.
also has same, the serial one
Whenever you
also.
don't
But you can see
define the output
for the serial code,
you run a C
the time taken was 0.6,
so new
and for the parallel code, it is 0.12.
then to execute
Yeah,
the
big
output
matrix.
file, you will do.
Yeah, overheads. Yeah.
So every time you compile the C,
So that is the end of
new
the
output is
lecture
generated.
slides.
If you don't
But we'll look at the online comments. Please raise your hands if anybody has any issue.
Here I have defined serial file. If I have not have defined serial file, directly if I have got serial file.
serial py.c without this O flag, then there is no need of then this there will be new additions. There will be new outputs. A dot
Stop recording.